Hello, everyone. I will get started. I think it's time. So hi, everyone. For those of you who do not know me, I am Johan Brichot. I'm a vast consultant and senior software engineer for instantiations. I will be talking to you in this presentation about the OAuth2 and OpenID Connect clients in the VAST platform. So first, there will be two big parts to the presentation. First, I will only focus on OAuth2. I will give a little bit of an explanation of what is OAuth2 and give you a demonstration. Actually, everybody in this room has already worked with OAuth2. I'll just also show how this works, how you can implement it, how you can use the client library, and how it's implemented using a C-side application in VAST. And then we'll move on to the OpenID Connect protocol, which is an application of OAuth2. I will also give a demonstration there in a C-side application that uses it, or a desktop Windows application where you apply it to do single sign-on, for example. Also a little bit about the integration with the VAST asynchronous framework, because this is an asynchronous protocol. It's very nicely integrated like that. Uses JSON Web Token as well. Won't go into much detail to that, but it's part of the presentation. So first off, OAuth2. What is OAuth2? So if you're in a situation where you are a resource owner and you are working with an application and you need to give that application access to your resources, this is where OAuth2 comes in. So and think about the resource owner as being me, and I have a GitHub account where my repositories and my code live. That's the resources I'm having, and I want to have this client application, which in our case will be a C-side or Windows application in the VAST platform. I want to give it access to my account on GitHub, which basically is all the code and all the rest of the stuff that's associated with my GitHub account. So one way to do this would be to give my credentials, my login and password to this client application so that it can log in and go through the API. So use that client application, will be able to log into the GitHub server and get all the stuff. But of course, this is not a good idea. I'm giving my login credentials to another application, which exposes all kinds of possibilities of people getting to my login credentials and using them somewhere else to get to my GitHub account. So OAuth2 protocol does is to separate this away and introduce an authentication server, which in this case would be the authentication server for GitHub, and me as a resource owner to authenticate directly with GitHub, entering my credentials at that point, and then have the authentication server give some credentials, which is called an access token, to the client application, and that client application can use that access token to contact GitHub on my behalf and get my information. So this is an indirect way. There's also other parts, of course, that this access token, why is it more secure, where there are not my credentials? There's also a limited time frame. It's also associated to the client application and many different things. Of course, at the same point, the access token, if it would be leaked, it could be used. That's, of course, always the case. But there is an additional level of indirection here that I won't be leaking my own login credentials there. Another thing which is important, or it's part of most of the use cases of OAuth2, is that the application developer also needs to register this client application with GitHub. GitHub needs to know for which application he will actually hand out access tokens. Strictly speaking, OAuth2 does not require you to. You can have open clients where you do not have this registration, but in most cases, you will require to register the client application so that GitHub knows who you are, who it's sending out an access token to, and also only allow that client application to use those access tokens. So that's the bare essentials of OAuth2. And what is it? It is an industry standard authorization protocol. It's not new. It exists for 15 years. But it's designed to protect a web service and define the authorization through delegation. I think that's clear from the schematic I was showing that this is through delegation. And it's also only HTTPS calls, of course. And something important to realize about OAuth2 is that it's a framework and there's many extensions. So when we started implementing the vast OAuth2 client, you can of course go with the original RFC, and then you have, I think, 10 or 15 other RFCs which apply and exchange and change, extend the original OAuth2 framework to be, well, for the future, actually going towards OAuth2.1. So, but the essence of OAuth2, or the intention, is that the user can authorize a client application or to use a service without actually sharing his or her credentials with that application directly. That's the essential of OAuth2. So, just give you everybody has worked with this because you've been using the web and you've been exposed to some service which of course uses OAuth2. But I'll demo it anyway because it demonstrates that the vast client library works. So to go for an OAuth2 application, you have to, and in this case, the demonstration for GitHub, something you need to do before is, as I explained, you need to register your application with the service. I did this before the demonstration, so I went to register a demo OAuth2 application with GitHub. And what's essential there is that for those who do not know OAuth2, I hope there are some, so that somebody is learning something from what I'm saying here. You actually get a client ID and a client secret. So that identifies your application. The client ID is like the public one, but the client secret is something you need to hide, which will identify this demonstration application, OAuth2 application for GitHub. So I went to register that. Another part which you have to assign at that particular moment is at what URL the OAuth2 authentication server will be able to deliver the authorization code in this case, but let's just simplify, actually the access token back. So you need to define where your own application is living, because you first delegate the user off to another website, to GitHub, and then this has to come back. And you have to define, for your application, it will live at this address. In this case, it will be a local demo, so this is localhost port 8888. Right, so this is the moment we go live. Okay. So in this case, it's a seaside application I will be showing you. So this is part of then, which inside of VAST, of course, it demonstrates how to use the library with Seaside, for example. So I will enter the client ID and the client secrets. And as you notice here, I already pre-filled the GitHub URLs for the service for the access token server. Nothing specific. Oh, I hope. Oh, great. What happens? Why? Let's see again. Okay. Wait. I think I made a mistake again. Oh, I did. Yes, I wrongly. Okay. Right. Oh, okay. I thought I logged out. Anyway, I will just leave it like that. The fact is that you didn't see anything happening. Normally, you would see the GitHub login prompt. Well, let's do it again. Well, no, everybody knows how this looks like. But I immediately was logged in, but this already demonstrates single sign-on, right? Because in my browser, I already had the GitHub cookie, so I was logged in, and I was immediately redirected, so I was authenticating with the service. Otherwise, I would have shown the GitHub login window. I would log in, and I would see this afterwards be redirected again. So all those redirections actually transparently and immediately happened in this demonstration. And the only thing I'm showing here as my demo application is just listing my GitHub repositories in this Seaside application. So that's the only thing. We'll not show you the access token, but you can, if you're doing this yourself, with the VAST demonstration, you're able to take a look at which access token it is. And in this case, GitHub gives me a non-refreshable access token. That's the way GitHub works. I'm not able to refresh this. So it will be valid for an hour, and that's it. So this works, of course. That's just to show you that it actually works. And then I'll go on. So how does the library look like? Because that's, of course, like the essence of the presentation. So the idea is that behind the scenes here, when you start configuring, I had the configuration parameters for my GitHub account. But in this case, I'm going to use a particular way, the most common way to use OAuth2, and that is through interactive login via the web browser, and that's called an authorization code grant. There's different kinds of grants, different kinds of flows to use OAuth2, for example. I will list them a little bit later. But what you do is you construct a grant object and you give it the parameters. You give it the client ID, which you got, your application client ID, and then both the authorization URL and the token URL. These are things you have to know as a configuration which OAuth2 service you are using. So you're actually creating that, and then you give optional parameters like your secret, or something which is very well known in OAuth2 is a scope. It's additional parameters to which parts you are authorizing your access token access to. For example, and this is to be defined by every service. For example, you can say, well, this application can have only read access to my public Git repositories, but this is up to the authorization OAuth2 service to define which kind of scopes you're passing. But anyway, you configure your grant object like that, and what the library, of course, does for you is it generates the URL to which you should send the user to so that he can authorize with the service. And then, of course, you're off to any way you like to implement this. You're using C-side, you're using the SST framework, you're using a desktop application, using WebView 2. So this can be many different ways to then redirect the user to the authorization service and get the answer back. And that's why there's this fictitious method, just explaining the flow. You redirect this user to the authorization URL, and then you handle the callback URL, meaning this case the local host. When I get the request back, it will tell me whether the authorization was failed or did it succeed, right? So that's where you need to handle that, and with the result of that request, you instantiate an HTTP client, which you are able to use to contact the resource server. And that's there at the bottom. So that's the result of the library. Once I am authorized, I get this HTTP client, which will just be able to use contact the API, which is protected by OAuth2. And by the way, this will then, if it's refreshable, it will automatically refresh the token for you. So it does some things which are intelligent if it's possible. So that happens behind the scenes. Now I will show how to do that in C-side then, this fictitious method of redirecting the user and getting the answer back, which you saw happening here. So first of all, what we are doing is generating a second callback URL. So we will be generating a callback inside of C-side and get the URL for that. And we will be passing that as the state parameter. And I'm sorry, I didn't introduce you with the state parameter, but it's one of the parameters you should also send along in the request to the authorization server, which can basically be anything. It should just be something unique. In this case, we just put in the unique URL of our C-side session so that when we handle the callback in the application, we know where to redirect to the original C-side session that was doing the authorization request. So that's basically what you're doing here. You're handling if I push the button, this is the code that's being executed inside of C-side. So just generating a unique callback and then redirecting the user to the GitHub login page and then listening for the request coming back and basically doing a lookup of the state parameter in order to redirect the user back to the original C-side session. So it's perhaps a bit quick to understand the complete flow here, but there's the demonstration for that in the C-side application if you're interested in using that. So what is essential here is, of course, that OAuth2 is a framework, and the VAST client supports many different ways of using it. As I said, the authorization or the grant that I was demonstrating is the authorization code grant, which involves redirecting the user via the web browser to the login page of the OAuth2 service and then getting the request back. This is the authorization code grant, and that's the class I was using to instantiate the first object to configure. There's then other classes inside of the client library which will implement the other grants inside of OAuth2. For example, the client credentials grant, that's more intended to be machine-to-machine communication and doesn't involve a user, doesn't involve like the interactive login through the web page. Now, every OAuth2 service is allowed to choose himself which kinds of grants they allow to implement, right? So this is not something you have an OAuth2 service and you have a choice between running any of these grants. Most commonly, you will only see that they implement the authorization code grant because the other ones are less secure. The client credentials grant is that there is no user involvement. There also is the implicit grant, but we do not support that in VAST because that's actually intended for running inside of the browsers themselves. VAST doesn't run in the browser itself. It will always be on your machine or as a server application, so we do not support that. There also is the resource owner password grant, which is basically giving your login credentials, and it was only intended as a compatibility to allow people to migrate to using OAuth2 and generally moving forward. So this is deprecated, though we have added it to it, but it's deprecated in OAuth2.1. They have removed it from the standard. There also is a JSON Web Token authorization grant, and this is where you will instead of sending your login credentials to log in, you will actually use a JSON Web Token, which requires a previously established trust relationship because you're signing, and the other service knows, oh, it's this guy because I'm getting the JSON Web Token signed with the previously shared secret. So also that is possible and supported inside of the client framework. We also applied, and in the demonstration a little bit later, on the native application. So using this inside of a native application has guidelines to how to handle this securely. And that's actually being, that's how we designed and how the demonstration for the desktop native application was developed. We also took into account, of course, the standards on the threat model and security considerations, which have been applied to the client library. For example, the PKCE, proof of key exchange. Now I kind of forgot the last two letters, if anybody knows. Anyway, that's an additional way of preventing, because if anybody else would be listening for the response coming back to the server, some other application, like on your mobile phones, you're being directed, you actually register the same URL. They could say, oh, I'm Facebook, and you get back from Facebook, you can actually intercept that. PKCE actually prevents those kinds of security attacks, for example. So all those things we incorporated to the RFCs from OAuth2, which are now being included as the ongoing progress towards OAuth2.1, is the design of the library has been handled in that way. So OAuth2 with existing extensions and additions, and without the secure options, that is OAuth2.1. This is how you should see that. All right. On to OpenID Connect. OpenID Connect is an application or an extension, depends on how you see it, as OAuth2 is an extensible framework, but it's an application of OAuth2 towards authentication of users. It's instead of just getting an access token and giving you access to a particular API, it's actually used to prove that a particular person is that identity, is that user. And so you will use this, instead of just exchanging an access token, you will get a JSON Web Token with the claims saying that this is this person who has logged in through the interactive login window. So it's typically used to do single sign-on, and as I mentioned before, it's what you saw happening with the GitHub application because I already was signed on. Lucky coincidence, I don't have to demonstrate that anymore. And it's definitely OpenID Connect. If people are working with SAML2, this is an easier implementation, an alternative protocol, which SAML2 I think is more complex, I think, as some of you know. So the idea here is, of course, to do the user authentication and identity management delegated to an external identity. Typically, you will develop your application and you will say people log in with your Google account or Microsoft account. So if I take the exact same schema as before, I just replace a couple of names, because if you take a look at the differences between which are used between OAuth2 and OpenID Connect protocol, is that you don't have an authentication server, but you have an identity provider. And you don't have the client application, but you have the relying party, for example. So the most important part, of course, is that instead of the access token, we're actually providing a JSON Web Token, which contains more information than just a random string, which gives me access to the resources here. Another part, which is part of the OIDC standard, is the fact that you have a URL where you can get more user information based on whatever user is identified inside of the JSON Web Token. Most of the time, for login and identity management purposes, it's enough the claims which are in the JSON Web Token. So it is exactly the same, but an additional thing that OIDC defines is that it has a discovery document. So if you remember, I had to start my application and say, well, this is the URL, the access token URL, the authorization URL, And these are all the configuration parameters, and you have to know the possibilities of the OAuth2 server. I will not go into detail, but you can have many different ways. Does it accept post request, get request? Is it basic auth? Should I use another kind of auth? So all these variances they can actually choose in the implementation of the OAuth2 server or the OIDC server. The thing is that they have a document, it's part of the standard. There should be a JSON document at a well-known URL, which actually specifies the options that this OIDC provider is foreseeing. So by reading that document, you can have an automatically configured client, which understands that I should do basic auth, I should do this, and if I try to set a particular parameter for the OAuth2 communication, it will tell me, sorry, but it's not supported on the server side. So that's the idea. The specific are the client library. You just point it towards that document and it will configure itself. So in the case, the most important ones are these endpoint URLs, the possible values for the different configuration parameters, which are many, and especially, of course, the encryption keys, which are used for the JSON web token, or the keys to sign that token. They are important to know, which actually can rotate, right? So Google refreshes them every 3 months. So if you're not keeping up to date and not looking at that location, then you will eventually have an outdated key and not able to do the verification of your JSON web token anymore. So same thing, I'll go to the same application here, but let's just start using Google. Well, just for certainty, I'll do this. I have also done the same thing, of course. I registered the Google application before, and look here, it's a bit the same. It's pre-filled, but it's not pre-filled in the same way. It's pre-filled coming from the OIDC discovery document, so not by me. And I'll just authenticate. Exactly, I have to, well, it's talking to me in Polish now. Anyway, okay, so the same thing happened. I was already logged into Google, but you saw that there was actually at least one step which Google put on there. So then with OIDC, I get a little bit more information. I still get my access token, but then I get the JSON web token, which actually says, yeah, it's Johan. Well, it should say it's Johan. Yes, exactly here. Well, what does it say? Oh, I should have added the scope email. Anyway, I don't have too much time left. But we're just showing the JSON web token here, and you use the JSON web token inside of your own application to say, oh, it's this user. A JSON web token is signed, so you can rely on it because the vast library will verify the signature, obviously, of the JSON web token. So if it's not valid, it will tell you, well, this something has been tampered with. And before I run out of time, of course, I showed this inside of a C-side application. I will show it to you in the desktop application, and this is then the demonstration. You can take a look, and you can take a look at the code for that if you want to use it. I'll just configure it as well with Google OIDC. Oh no, I think did I take the Microsoft one? Anyway, we'll see. I'll authorize in the browser. So the recommended way of working with the authorization code grant inside of a desktop application is to redirect, and I took the wrong one. I should use Microsoft. So to redirect the user to an external web browser. We also have the option to run this inside of WebView 2, and we have the code to show it if you really want somebody embedded in your own application. But out of security considerations, it's better to use a real web browser. People should be used to seeing the real URL. And also, there is as a user, I'm not exposing, at any point, I'm exposing my credentials to the client application. It always will go to Microsoft in this case. So let me just log into Microsoft, so at least I have exactly, now I have to quick copy paste, all right. No. Now I'm showing you a very ugly landing page. So this is where I'm handling, the desktop application is handling, or it's set up a temporary web server, and it's handling the response, and it's showing a web page that, okay, you're successfully authorized. But the only thing I do here is just echo the request. Of course, as a real application developer, you put something really nice here. Didn't go through the trouble of that. I'll close the browser, and actually what happened is that the access token here, you don't see everything, so that's fine, and it's only valid until 1 hour. So it's actually here, but let's open the inspector on the credentials, and this is all the credentials that it's keeping. It's keeping the access token, but I'll go to the JSON web token and to the claims, and you can see exactly the same. So I'm Johan at Inceptive BE, for example, and this is the thing inside your application. Well, not on the, you should use my unique ID at Microsoft to verify that it's really me using your application, but it has some additional information about who I am. I'm not showing you the signature, but that's verified, and I'm not showing you because then you know the entire JSON web token and you will be able to compromise me on Microsoft. Right, and then I'll quickly go back to my slides. Back to my slides, yes. All right, so actually the same thing happens, but I just wanted to show one thing. So inside of a C-side application, it's difficult to use the asynchronous framework for VAST because that means spawning processes inside of a request. Doesn't work well. But the library here integrates well with the asynchronous programming framework for VAST, and it works well inside of a desktop application because think about it, you're just spawning another process because this user has to authenticate and you're waiting for a response, which is an asynchronous programming characteristic. So you're just waiting for that response. And we have a convenience method with that. The only problem is it looks a little bit complicated because it's open for different ways of launching this redirection. Whether you would be using an external web browser, WebView 2, C-side, whatever. There's different ways of redirecting the user in another browser and getting the response back. But giving this convenience method, actually it returns you a future. And then you can say, well, when I get the authentication back, once this is when the future will be resolved, right? Okay. So, and what is being resolved is I get the HTTP client with access, with the access credentials I just obtained, and I can call it to call user info or just get the credentials from it. So this is a subclass of the existing SST HTTP client, right? So it's completely compatible. I don't have too much time left, a couple of minutes, but yeah, so JSON Web Token, I didn't really go into detail there, but what is important to understand here is that a JSON Web Token is signed, and when you receive it and you verify the signature, and that's what the client library does for you, it uses the keys it's obtained from the meta document of the provider, and it verifies the signature of it, and you can be sure whatever is inside the claims that they are real, right? Nobody has tampered with it. They are not secret, but they are real. So that's the thing, and that's why you can use this as a real proof of identity. And it's a separate VAST library, so a JSON Web Token library will also be part of that. I demonstrated it like that. Another thing is that if you take a look at many different OAuth2 and OIDC APIs, you will notice that many of them define additional parameters. So if you were using this library and you wanted to pass other parameters to the requests, then it allows you to do so in a generic way. So you can always add any authorization parameter. The thing what we did is we added some conveniences which already implement a complete API for Google and Microsoft OIDC. Those are very commonly used, especially in corporate environments. The Microsoft OIDC is a popular one. Well, Microsoft Entra. So finally, the VAST OIDC library, it also passes all conformance tests of what is called a basic relying party profile. It's basic, and that's the only thing you need. It's not basic in really minimal. It just says this is the essential part of the OIDC protocol, and so it passes the conformance tests online for that. So it could be certified if that is warranted. So what we did is we showed you some client support for OAuth2 APIs and OpenID Connect. The resulting client is completely compatible with the existing SST HTTP client. We have some convenience methods for people working with Microsoft Entra and Google OIDC. Showed you a desktop and C-side example, so they're actually included. How can I use this library in my particular context, developing a web application or a desktop application? And it has a convenience integration with the VAST async framework. And then, well, for those users of VAST, most importantly, this will be included with VAST 15, VAST 2026. But if you're really interested, and I hope there's a couple of people, we can give you a preview to be run inside of VAST 14 if you want to start playing with it. And that's it. Thank you for listening. Questions? Any questions? Everything was clear or not clear at all? Too many questions.
I suppose this is a vast part and not, can it be used also in other Visualworks or in other Smalltalks, or is it just a vast part?
It's a vast part, yes. So the implementation it's only created for running inside of VAST. We use a couple of things which we only have available in VAST. So yeah, it's a vast application. But if you want to know more about just implementing or you have questions about it, please talk to me. Really happy to share that knowledge. But yeah, it's a vast application. Same question.
I just wanted to go one step. The point is, yeah, if it uses VAST internals, it's okay, but the licensing of the code is more interesting.
Yeah.
So
no.
can we steal it?
No, it's part of the VAST shipped code, yes.
Okay,
yeah.
Thanks.
Are you planning to also implement something for the resource server so that I can implement a resource server? Not the authentication part, but the resource server?
Actually creating a resource server, that is really easy because you just have to know the access token, because the only thing that comes in is in an authorization header, which is a bearer header. Actually, it's already in VAST 14, that one. You can actually implement an API which would use the result of an OAuth2 authentication. But the authorization server, that's another thing. There's no plans. No.
I guess so, but I mean, this is a very Smalltalk-ish answer, because everything is easy in Smalltalk. So, but do you have plans to implement that stuff? I mean, can you give me some code?
Yeah, sure. It's a good idea. We'll probably just add that as an example of yes, because actually in the tests there is. But I didn't demonstrate it, right? But in the tests there is, because, but yes, but the authorization server not, but the resource server, that's, yeah.
Yeah, just want to add, because scopes is the one thing that is the generic way of, that if you get an authorization for a scope, and you get that in your user server and you validate that the JSON web token is valid, then you can look at its scope in order to get access to the capabilities. So that's the
yeah, but
way
indeed,
of
the
doing
scopes are, of course, application specific. So you define your own based on whatever is in there, right? So there are a couple of ones which in OIDC, which are defined scopes, which an OIDC server will implement. But in general, if you define whatever kind of thing you will define as scopes, is something you use inside of your resource server. But yes, good suggestion, Joachim. We'll do that.
Thank you very much, Johan, for your nice presentation.
Thank you very much.
Now, is Nahuel that is going to be presenting, so about JIT compilers.